Suppose we have a data set that consists of some test scores. If a teacher gives a test, a couple of questions that the teacher might want to have answered is, how well does this test actually assess what was being taught about the material that was on this test? And from the other perspective, the question might be asked, how well did I teach the material that I included on this test? And when we look at these data values, they're pretty good. We've got a 95, a 92, 85, 83, 82, 82, 81, 79, 76, 76, 76, 75, 74, but then we got this 42 right here. And a question might come up, well, what happened with this 42 right here, and does it really belong in the data set? Well, in order to answer this question, we are going to first look at what's called the 5-number summary. The 5-number summary would consist of the minimum value, which for this data set is easy to see. That would be 42. The maximum data value would be 95. The median is the value that cuts the data set in half. 50% of the data values would be less than the median and 50% would be greater. And if we look at this data set, it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 data values in it. So since there's an even number of data values, we'd look at the average of the middle two. So counting 7 from either direction, 1, 2, 3, 4, 5, 6, 7, we land here in between 81 and 79. So the median would be the average of those two values, so we would have 80 as our median. Now Q1 is the abbreviation for the first quartile, where the median breaks the data values up into two pieces, the bottom half and the top half. The first quartile, and you think about the word quartile, that would sound like it's breaking it up into fourths. And that's what that's about. The first quartile would be that point where 25% or 1/4 of the data values are less than that value, and 3/4 or 75% are greater. And really then what that turns out to be is just the median of the bottom half. So we look at the bottom half, and there's 7 data values in that set, and that's an odd numbered set of data. So we would look and say, okay, then the first quartile is going to be 76. The median of the bottom half, counting 4 from either direction. Likewise, the third quartile is going to be that point where 25% of the data values are greater than that and 75% are less. So that's just going to be the median of the top half. 7 data values in the top half, count 4 from either direction, 1, 2, 3, 4. And we find then that our third quartile is 83. From this set of values, we can construct what's called a box plot. It is very important that a box plot is scaled. So I've drawn this range of the number line here from 40 to 100 and tried to separate the tens off as evenly as possible. The way a box plot is constructed is by putting a dot above this x-axis here at the point where the minimum value is, and then labeling that minimum value, 42. Then a vertical line will be drawn at the first quartile, and it'll be drawn in such a way that a horizontal line would connect that minimum value dot to the midpoint of that line segment. And then we would draw another vertical line segment at the median, another vertical line segment at the third quartile, and then label all these things as we go, 76, 80, 83, and then another dot at the maximum value, label that, and connect it in the same way that we did the minimum value. And then we're going to draw some horizontal lines that will enclose this little box here that represents this range of values from the first quartile to the third quartile. And then we can take a quick glance at this thing and see that, we appear to have some clustering of data. The span from the first quartile to the maximum value, so in other words, 75% of the data, the top 75% of the data, span from 76 to 95, which is a range of 19 units. The bottom 25% span this range from 42 to 76, which is a difference of 34 units. So we appear to have data values that are clustered towards the top,